Okay, we will still continue with the work. So work is equal to 0 when what? Okay, there's no movement, no force. What else? If the angle is 90 degree, for example, theta is equal to 90 degree. So equation that you will use for work if there's an angle, if F cos theta D, right? So W is equal to F cos 90 times distance. Distance, you don't know. So cos 90 itself is equal to 0. So 0 times any other value, you will get 0. So work is equal to 0 if the angle is 90 degree. Okay, what else? Work will be positive. This is just a concept of work. Okay, work will be positive if F, force and distance in the same direction. You will get negative work if F and D opposite direction. Okay, give me an example of F and D in the same direction. Okay, very good. F and D in the same direction. For example, object, force, and the object move to the right. So here will be the object. So the distance to the right. So F and D in the same direction. It will produce the positive work. How about negative work? Negative work when force and distance in the opposite direction. What does it mean? What force in the opposite direction with the movement, right? So of course, if there's a force forward, of course there will be a friction force. Friction force is the force opposite direction with the distance. Okay, now we move to example. Example 1. A weightlifter lifts a 350 Newton sets of weights from ground level to a position over his head and vertical distance of 2 meters. Okay, now the distance in y-axis. Just now I told you in x-axis, right? So it still have movement in y-axis. It's not 90 degree. Okay, how much work does the weightlifter? Okay, this one is a very simple equation. So you just use what equation? Okay, here you have force, here you have distance. So what equation to find work? So work is equal to FD, as simple as this. So work is equal to 350 times with 2 meter. 2 meter already in SI units, so just put 2, which is equal to 700 joule. Okay? If the unit in centimeter or millimeter, you should convert to SI unit, which is meter, because Newton, if Newton unit is kilogram meter per second squared. So in the whole equation here, you should use SI unit. Use SI unit. Okay. The first one only 2 marks. Okay, equation half marks, 1 mark. Okay, now we move to example 2. Still in work subtopic. A lawnmower is pushed a horizontal distance. Okay, now the object move in x-axis of 20 meter by a force of 200 Newton. So here will be the distance. Here will be the force. If you don't know what is this, even though it's given here a force of 200 Newton, means it is the force, right? Horizontal distance of 20 meter means distance is the D. Okay, but if you still blank, please look at the unit. Newton is the unit for force. Meter is the unit for distance. Okay, directed at angles. So here will be theta with the ground, means on x-axis. What is the work of this force? So find the work done. Of course, if you have theta, you have to use what equation? Work is equal to F cos theta D. Don't forget the distance here, okay? Okay, so work is equal to force 200 cos theta is 30 degree times with distance 20 meter. So work is equal to 200 cos 30 times 20. 3,464 joule. Okay, if there's an angle, you just use cos, and it move in x-axis, of course you have to use cos. Okay, because 30 degree with the ground, it means like this. Here is x-axis, here is 30 degree. 30 degree with the ground means on the x-axis. Okay, that's all for work. In the next video, we will proceed with the energy. We will have types of energy. We will discuss in the next video. Thank you.